I'm back with the bang, or should I say thunderstorm. I will be creating this skybox effect using shader graph, and I'm using Unity 6, and my project is set up in URP. Alright, now it's time the skybox series make a comeback. Alright, so I have this simple scene, and the most notable thing is this global post-processing volume that has the module tone mapping with the mode aces, and this bloom. Now first, let's create a shader graph. So shader graph URP, and make sure to select unlit shader graph. I'm going to call it thunderstorm. Then we will need a material for that, so keep your shader selected, right click, create material. Let's also call it thunderstorm. Then in the lighting window, go to this environment tab, and in the skybox material slot, just assign our newly created material. In shader graph, in the graph setting, make sure that the active target is universal and your material's type is unlit. And if you have this allow material override check, make sure to uncheck it, and also uncheck this cast shadows. Then select your material, and in the inspector, come to this advanced option, and in this queue control, we will going to override our render queue. Make sure to input 2500 so that your material will render after all the opaque objects and objects with alpha cutout, but before the transparent object. Then in the lighting window, you will get this warning that shader of this material does not support skybox rendering. But if you follow everything that I've just shown, it will work just fine. At least it will work in the Windows build. I've just tested myself. But I don't know, for some reason there's something going on with Unity. Anyway, if you think that this warning is annoying, just select your shader graph and rename it to include skybox in it, and the warning will go away. I don't know why, but that's the way to do it. Now to draw anything in the shader, we need UVs. And now, if I remember correctly, back in Unity 2022-2023, this UV is used to return the polar coordinates. But in Unity 6, they've changed something, so this UV now actually returns the vector 3 world direction, or direction in world space. Think of them as a normals. So let me just show you. So you can see that it will have 3 components. Let me just show you with the swizzle node. So the X values will be positive in the right side and negative in the left side. Y will be positive upwards and negative downwards. And Z will be positive forward and negative downwards. Backwards. Like this. Now for the UVs, we will use the XZ component. So this one. And you will have origin 00 in the middle, and the X will go positive like this and Y positive like this. Now I know it looks weird, but that's just because I've applied the ACES post-processing. Otherwise you will get the nice actual UVs. Alright, we will use this UVs. And now to prevent the shader graph from becoming a spaghetti noodles of different nodes, I'm going to use a subgraph for the lighting bolt itself. And for this one, I know I'm going to be in a way, actually let's just do it like this. So right click, shader graph, and subgraph. Let me call it lightning. Then in my subgraph, I'm going to open up the blackboard and the graph inspector. Then in the blackboard, I'm going to create a property which will be the input in this case. Let's call it UV, and we are going to use the UVs in the swizzle node that we have just created, and then select this output node, and it will return a color, so vector 3, and let's call it lightning. Right, let's drag and drop our input UV. Now we are going to use this UV for everything here, but just to show the previews and the shader graph itself, I'm going to use the UV node. And now to create the lightning bolt, I'm going to create a glowing line segment, which will be sitting between two vector 2's. So let's create vector 2's first. You can always make them as property. So let's say the starting point will be 0.2, 0.2, and ending point will be 0.8, 0.8. Now I'm going to calculate a vector that points from this point to our UVs. So let's take our UVs and feed it into the subtract node's A input. Then take our UVs. Then I'm going to create another subtract node. And then I will create a vector that points to this vector from this vector. So take this and feed it into A, and this vector into B. Then let's calculate the dot product between these two. So dot, and I'm going to divide that with the squared length of this vector. So that will be dot product of this vector itself, and feed it into this divide node. Now I have to make sure that this value can't go beyond 0 and 1. So I'm going to just feed it into saturate node. Then I'm going to take it and multiply it with this vector. Then I will take its output and feed it into another subtract node. Then take this subtract node's output and feed it into this B. And then just simply take this output and feed it into the length. So here we will get the distance to the closest point on the line segment from our UVs, and it will look like this. And just to keep things tidy, I'm going to select all these nodes and group them. And let's call it line SDF. And if you want to know what is actually going on behind all this calculation, I've just released a video regarding line SDF. You should definitely check it out. Alright, now I can cut out a nice line from this using smooth step. Like this. But I want this line to be glowing even without the bloom post-processing module. So instead of this, I'm going to use divide node. In the A, I'm going to input some smaller value and take our length node's output and feed it into the B slot. And we will have this nice glowing line. Then let's color it. So let's create a color node. And you can of course make this a property, but I'm just going to keep it like this. And the lighting in real life will be in like pinkish sides or violet side. And let's multiply these two. So just like that. And then take this output and feed it into our output. Now I also want to distort this line, and for that I'm going to use simple noise. And we are obviously going to use this UV, but just for the preview. And let's set the scale to, I don't know, 20, and take its output and feed it into remap node. So the original will go from 0 to 1, and let's remap it to minus 0.2, 0.2. Then let's split our UVs. And I'm going to distort the X component using this noise. So let's add our noise, remap noise, and take our X. And then let's again combine it into vector 2. So X, and for our Y, we will directly pass in the Y. And then I'm going to take this and feed it into the UVs. So you will get this distorted line. And now I'm just going to use my input UVs instead of this actual node, and it will break the preview, but don't worry. Then in our thunderstorm skybox shader graph, let's drag and drop our lighting subgraph, and let's use this UVs, and let's check how it looks. So I'm going to have this lighting bolt like this. Now it also goes in the ground, but we will fix that in a bit. But first we have some artifacts. And the reason is this node's output could technically go beyond 0 and 1 range, so let's just clamp it using saturate node and use that instead. So now I'm going to have this nice distorted lighting bolt. And now let's make sure that we only have lighting in the sky and not in the ground. So I'm going to use another swizzle node, and I'm going to use the Y component, just like that. And then let's multiply these two together. And use this multiply in the saturate node instead. So now I have this bolt in the sky. Let's come back to the subgraph. And now I can alter the look of this lighting bolt by offsetting this UVs before inputting in this simple noise. So I can just add some values to it, like, and then use this to make it look like this. Similarly, I can shift the position of it by again offsetting the UVs before calculating my line SDF. So let me just show you, just like that. I can also control the size of the lightning bolt by multiplying some values before offsetting it, just like that. Also, I can rotate the lighting bolt before I can multiply. So let's use rotate node. Let's keep the center 0, 0. And it's up to you what unit you want to use. I'm going to use degrees, and let's say 90. Just like that. Now I want to change the input of all these nodes over time randomly. So for that, I'm going to use another input property. Let's call it time, or T. Let's drag it in. And I'm also going to use another float property. Let's call it seed refresh. Drag it in, and let's set the default value to be 1 for now. Let's take our T and feed it into divide node and divide it with our seed refresh. Then take its output and feed it into ceiling node. Now ceiling will just return the nearest integer, which will be greater than our input value. So if we input 1.01, we will get 2 as a result. Now in the ceiling node, we will get a random seed, which will update every seed refresh second. So let's take its output and feed it into random range node. Now random range node will get the job done, but for better control, you should implement your own hashing algorithm for this one. Alright, now let's keep the minimum 0 and maximum to 360. So we will get a random number between 0 and 360, and I'm going to use this as the rotation. Then let's duplicate it, and let's keep it 1 and 5. You can tweak these values, by the way, and let's use it as this input. Then let's again duplicate it, and this time let's go -2 and 2, and I'm going to duplicate it once more. Now both of this node will return the exact same output because we are feeding the same seed. So for this one, I'm going to add something. let's add some, whoops, let's add some value like 1, 2, 3, and then feed it into seed, and then let's combine these two. So now I will have a random vector 2 which will go from -2 to 2 in both x and y, but they will be different. And then let's use it for the offset of our lightning bolt, and let's remap this value, which is original -2, 2 to go 0 to 100, and then use it for our offset of our noise. Now in the line SDF logic, let's keep our starting point at 0, 0 and ending point at 0 and 1. Then in our thunderstorm shader graph, let's create a time node, take the time output and feed it into this T slot, and in the seed refresh, let's pass in 0.1, or that would be too fast. Let's pass in 0.3. So this simply means we will get a new seed every 3/10 of a second. Let's save and let's see how it looks. So I'm going to have a random lightning bolt every 3/10 of a second. Now in the lighting subgraph, let's increase our scale for the simple noise. Let's change it to 30. And this is the part where you have to tweak the values until everything just looks right. Right? That looks fine for me for now. Now let's make this lightning bolt flicker. So for that, let me create a gradient node. Let me define a gradient real quick. So it will be black. Whoops, what happened? Black. Okay, so I've created this sort of gradient. Now let's take its output and feed it into sample gradient node. Now this time input, if I pass in 0, I will get the color from the left of the gradient, and if I pass in 1, I will get the color from the rightmost part of this gradient. Okay, so I'm going to take this divide node's output and feed it into the fraction node, and fraction node simply returns the fraction part of a number. So if we input 3.25, we will get 25. Even if you pass in negative values, you will get the positive. Okay, now let's take the fraction node's output and feed it into this time, and we can't see proper preview. Then I'm going to take this output and feed it into multiply node, and I'm going to multiply it with my final output like this, then take its output and feed it into our output node. And now you can see my bolts are flickering. That's pretty cool, but now I want to make them a little bit brighter. So in this divide node, let's use 0.02 instead. Okay, that's too much. So 0.01 maybe. Yeah, that will do for now. And again, this is the tweaking part. Okay, now back in our thunderstorm shader graph, I can duplicate this node. That's a subgraph. Let's pass in some different seed refresh, so 0.5. And for the time, I'm going to add something like 987.127, for example, and then use that instead. So I will get a different lightning bolt than this one. Then let's add these two together, and then take this and feed it into this multiply, so I can have two bolts. Now, of course, just like this, you can add multiple lighting bolts, but just keep in mind that every time you use a new lighting subgraph, you will make your shader more expensive. Alright, now that was the basic for the effect, and now it's up to you how to use this on top of your additional Skybox rendering logic. Let me just give you a quick example. Let's say I have a cube map, so I already have one. Let's use this one, and I'm going to add this on top of my lighting bolt like this, and then just take its output and feed it into saturate node. And my cube map is not looking nice, so I'm just going to take my UV and feed it into this direction input. It will break the preview but work on the actual scene, just like that. Now, one thing I don't like is that it looks like the lighting bolt is getting drawn on top of this cloud, so let's try to fix it. So for now, I'm just going to disconnect this direction node so we can see the preview here, and then I'm just going to take any single channel. Let's take in blue channel, and then let's create a mask from this. So let's feed it into smooth step. Now let's say for values that are less than 0.02, I need black values, and for values that is greater than 0.1, I need white values. Okay, it looks something like this. Let's tweak it a bit more. Okay, first I'm going to multiply with some bigger number and then use that as input instead. So now I can actually tweak it a bit more precisely. Okay, so this looks nice to me. And then instead of this mask, I'm going to use this in this multiply, and so we don't need swizzle mode anymore. And it breaks, but I need to use this input UVs here. And now it looks like the lighting bolt actually goes behind the clouds, which is pretty nice. But now it's up to you how to tweak the shader according to your requirements. And there we have a thunderstorm shader. I hope you liked it. That's it from me, and I'll see you in the next one.